Hi, my name is Joshua Cook, and I'm a curriculum developer with Databricks. In this video, we're going to be continuing our latent semantic analysis work. One advantage of working in Databricks is that the Databricks runtime for ML contains many popular machine learning libraries such as Scikit-Learn, TensorFlow, and XGBoost. We will use the Databricks runtime for ML to implement our latent semantic analysis in Scikit-Learn. There's a link to the notebook I'll be using in the video description if you would like to follow along. Here we're going to do a latent semantic analysis on a body that represents two popular children's books, Goodnight Moon and Where the Wild Things Are. As before, the first step is to collect the raw text data that we will be working with. Here we use Spark to load the text data into a data frame. As you can see, each document represents a line of text from one of the two books. For example, from Goodnight Moon we have "and a little toy house" and "a young mouse." From Where the Wild Things Are, we have lines such as "that very night in Max's room a forest grew and grew." Next, we convert the Spark data frame to a Pandas data frame so that we can use it with Scikit-Learn. Note that I've also collected a few sample indices for a few sample documents so that we can look at them later on in the process. Next, we'll prepare our document term matrix. As before, we will use the count vectorizer model in Scikit-Learn. This time, however, we will be passing a few arguments to our count vectorizer model. In particular, we will use the min_df argument, which specifies a minimum number of documents in which a word must appear to be counted for the analysis. We also will specify to use the English stop words. Recall that in the first analysis, the word "the" was the most important word in the entire analysis. Using the English stop words will mean that common words like "the" will not be included in the analysis. As before, we import the count vectorizer from sklearn.featureextraction.txt. We then instantiate a new vectorizer with these arguments and use it to fit and transform our body into a bag of words. As before, our third step is to perform a singular value decomposition on the document term matrix. Again, we do this using the truncated SVD model. We instantiate an SVD and then use it to fit and transform the bag of words into an LSA. Finally, let's have a look at the topic encoded data generated by this process. Notice I'm also adding a new column of data, is wild things, which is just a Boolean vector indicating whether or not the document comes from the book Where the Wild Things Are. Here are displayed the results for the 5 sample documents from before. Notice for the column is wild things, it's true for the first document because it comes from Where the Wild Things Are, and false for the others, which come from Goodnight Moon. Here we show the topic encoded data. Recall that there are two important byproducts from a latent semantic analysis, the dictionary and the encoding matrix. Once more, we show the dictionary using the getFeatureNames method. Here are the first 10 words in the dictionary: air, away, balloon, bears, bed, best, blinking, boat, bowl, and brush. Here we show the encoding matrix. Recall that each numerical value here represents the expression for a given term. For example, the word bears has a very small expression or loading for the first topic, and an expression or loading of about 0.04 for the second topic. We can use the absolute value of these numerical values in the encoding matrix to help us interpret the topics. Here we create absolute value columns and then sort by the absolute values of topic 1. With this sorting, we can see that the most important words for topic 1 are terrible, wild, things, gnashed, roars, teeth, roared, eyes, and showed. All of those words sound like they come from Where the Wild Things Are. Next, we sort the encoding matrix by the absolute values of topic 2. Here we see the most important words are good night, whispering, hush, lady, old, moon, brush, mush, and comb. All of those words sound like they come from Goodnight Moon. So we can see with this topic analysis that we've generated two topics, one of them corresponding to Where the Wild Things Are, and the other corresponding to Goodnight Moon. This is the power of a latent semantic analysis. We have applied linear algebra to a text data set, and it's telling us things that we would know intuitively. Let's plot the topic encoded data using the Python library Matplotlib. Here I'm generating a scatter plot for each book. I'm doing this so that I can encode one book as red and the other green for easy visualization. Here is the plot we've generated. Here we can see a clear correlation between each book and the axes. Where the Wild Things Are lines up nicely with the horizontal axis, whereas Goodnight Moon is almost completely on the vertical axis. One thing we will notice is there's a bit of noise with regard to the encoding of the Where the Wild Things Are documents. In particular, look at this point right here. It has a very large value along the horizontal axis, corresponding to where the wild things are, but it also has some representation in terms of Goodnight Moon. In the next video, we will look at a modification to the latent semantic analysis process in the hopes of reducing some of this noise.